A Bluffer's Guide to Blockchain, 100 Knowledge Snippets. So here's my top 100 snippets of knowledge for blockchain. Blockchains use public key encryption to integrate digital trust. Bob signs for a transaction with his private key, and Alice proves this with Bob's public key. The first usable public key method was RSA and created by Rivest, Shamir and Edelman. It was first published in 1979 and defined in the RSA patent entitled Cryptographic Communication System and Method. Blockchains can either be permissioned, requiring rights to access the blockchain, or permissionless, open to anyone to use. Blockchain and Ethereum are the two most popular permissionless blockchains, and Hyperledger is the most popular permissioned ledger. Ralph Merkle, the boy genius, submitted a patent on the 5th of September 1979, and which outlined the Merkle hash. This is used to create a block hash. Ralph Merkle's PhD supervisor was Marty Hellman, famous for being the co-creator of the Diffie-Hellman method. David Chaum is considered as one of the founders of electronic payments, and in 1983 he created eCash, along with publishing a paper entitled The Blind Signatures for Untraceable Payments. Miners gather transactions on a regular basis, and these are added to a block, and where each block has a Merkle hash. The first block on a blockchain does not have any previous blocks and is named the Genesis block. Blocks are bound in a chain, and where the previous, current and next block hashes are bound into each block. This makes the transactions in the block immutable. Satoshi Nakamoto worked with Hal Finney on one of the first versions of Bitcoin, and which was created for a Microsoft Windows environment. Craig Stephen Wright has claimed that he is Satoshi Nakamoto, but this claim has never been verified. Most blockchains use elliptic curve cryptography, ECC, a method which was created independently by Neil Koblitz and Victor S. Miller in 1985. Elliptic curve cryptography algorithms did not take off until 2004. Satoshi selected the SEPT 256 key 1 curve for Bitcoin, and which gives the equivalent of 128-bit security. The SEPT 256 key 1 curve uses the mapping of y squared is equal to x cubed plus 7 mod p. This is known as a short Weierstrass curve. The prime number used in SEPT 256 key 1 is 2 to the power of 256 minus 2 to the power of 32 minus 2 to the power of 9 minus 2 to the power of 8 minus 2 to the power of 7 minus 2 to the power of 6 minus 2 to the power of 4 minus 1. Satoshi published a 9-page white paper entitled Bitcoin, a peer-to-peer electronic cash system, as a white paper on the 31st of October 2008. In 1997, Adam Black introduced the concept of proof of work of Hashcash in a paper entitled Hashcash, a denial of service countermeasure. This work was used by Satoshi in his white paper. Satoshi focused on a decentralized system, a consensus model, and addressed areas of double spend, Sybil attacks, and Eve in the middle. A Sybil attack is where an adversary can take over the general consensus of a network and leads to a 51% attack, and where the adversary manages to control 51% or more of the consensus of the whole network. Satoshi used UK spelling in his correspondence, such as using the spelling of honour with a U. The first Bitcoin block was minted on the 3rd of January 2009 and contained a message of Chancellor on brink of second bailout for banks. This was the headline from the Times as published in London on that day. On the 12th of January 2009, Satoshi sent the first Bitcoin transaction of 50 Bitcoins to Hal Finney. With Bitcoin, a new block is created between every 7 and 10 minutes. In August 2023, the total Bitcoin blockchain size is 502 gigabytes. At the current time, there are 3 top cryptocurrencies. These are Bitcoin, Ether, and Tether. Bitcoin has a capitalization of $512 billion, Ether with $222 billion, and Tether at $83 billion. The total cryptocurrency capitalization at the current time is $1.17 trillion. The original block size for Bitcoin was 1 megabytes, but recently upgraded to support 1.5 megabytes and has around 3,000 transactions. Current block sizes are more than 1.7 megabytes. Bitcoin uses a gossip protocol named the Lightning Protocol to propagate transactions. A Bitcoin wallet is created from a random seed value. This seed value is then used to create a 256-bit SEPT256 key1 private key. A wallet seed can be converted into a mnemonic format using BIP39, and which uses 12 common words. This is a deterministic key and which allows for the regeneration of the original key in the correct form. BIP39 also allows for the conversion of the key to a number of languages, including English, French, and Italian. A private key in a wallet is stored in a WIF format, WIF format, and which is a base 58 version of the 256-bit private key. The main source code for the Bitcoin blockchain is held at github.com/Bitcoin and is known as Bitcoin Core. This is used to create nodes, store coins, and create transactions with other nodes on the Bitcoin network. A 256-bit private key has 115,792 billion different keys. There's 8 billions in there. That is 2 to the power of 256. A public Bitcoin ID uses base 58 and has a limited character set, and where we delete the 0, the lowercase l, and a capital I, as these can be interpreted as another character. In Bitcoin and Ethereum, a private key is converted to a public key with a private key of X is converted to a public key with X, G, and where G is the base point on the SEPT256 key1 curve. An uncompressed SEPT256 key1 public key has 512 bits and is an XY point on the curve. The point itself starts with a 04. A compressed SEPT256 key1 public key only stores the X coordinate value and whether the Y coordinate is odd or even. It starts with a 02 if the Y coordinate is even, otherwise it starts with a 03. In 1992, Eric Hughes and Timothy May and John Gilmore set up the cypherpunk movement and defined, "We, the cypherpunks, are dedicated to the building of anonymous systems. We are defending our privacy with cryptography, with anonymous email forwarding systems, with digital signatures, and with electronic money." In Ethereum, the public key is used as the identity of the user, that's A times G, and is defined as a hexadecimal value. In Bitcoin, the public ID is created from a hash, a SHA-256 hash of the public key, and then a RIP MD160 hash of this, and then converted to base 58. In computing the public key of ECC of A times G, where G is the base point on the curve, we use the Montgomery multiplication method, and which was created by Peter Montgomery in 1985 in a paper entitled Modular Multiplication Without Trial Division. Elliptic curves use two basic operations: point adding P plus G, P plus Q, and point doubling 2 times P. These can be combined to provide a scalar operation of A times G, where G is a base point. In 1999, Don Johnston Alfred Menezes published a classic paper on the elliptic curve digital signature algorithm ECDSA. It was based on the DSA digital signature algorithm method created by David W. Kravitz in a patent which was assigned to the US. The core signature used in Bitcoin and Ethereum is ECDSA, and which uses a random nonce for each signature. The nonce value should never be repeated or revealed. Ethereum was first conceived in 2013 by Vitalik Buterin and others. It introduced smaller blocks and improved proof of work and smart contracts. Bitcoin is seen as a first-generation blockchain and Ethereum as a second-generation one. These have then been followed by third-generation blockchains such as IOTA, Cardano, and Polkadot, and which have improved consensus mechanisms. Bitcoin uses a consensus mechanism which is based on proof of work, and where the miners focus on finding a block hash that has a given number of leading zeros. The difficulty of mining is defined by the hashing rate. At the current time, this is around 424 million tera hashes per second. There are around 733,000 unique Bitcoin addresses being used. Satoshi defined a reward to miners for finding the required hash. This was initially set at 50 Bitcoins, but was set to half at regular intervals. On 11th of January 2021, it dropped from 12.5 Bitcoins to 6.25 Bitcoins. Bitcoin currently consumes around 16.27 gigawatts of power each year to produce a consensus. This is equivalent to the power consumed by a small country. In creating Bitcoins, Satoshi used the P2PKH or Pay to Public Key hash address. These addresses are used to identify the wallet to be paid and links to the public key of the owner. These addresses start with a 1. In order to support the sending of Bitcoins to and from multiple addresses, Bitcoin was upgraded with SegWit, defined in bit 141. The wallet address then integrates the Pay to Witness public key hash or Pay to Script hash P2SH. These addresses start with a 3. Ethereum uses miners to undertake work for changing a state or running a smart contract. They are paid in gas or ether, and which relates to the amount of computation conducted. This method limits denial of service attacks on the network and focuses developers on creating efficient code. Ethereum supports the creation of cryptocurrency assets with ERC20 tokens, and which are defined as FT or fungible tokens. For normal crypto tokens, there is a finite number of these, and each of these are the same. Ethereum also uses NFTs, non-fungible tokens, and defined by ERC721 tokens. We mint these each time they are needed, and each is unique. Solidity is a programming language used in Ethereum, while Hyperledger can use Golang, Node.js, and Java. For Ethereum, we compile Solidity code into EVM, or Ethereum Virtual Machine code. This is executed on the blockchain. Blockchain uses a SHA-256 hash for its transaction integrity. Ethereum uses the Ketcha hash to define integrity of a transaction. This is based on SHA-3 and which differs slightly from Ketcha. The Ketcha hash family uses a sponge function and was created by Giulio Bartoni, Joan Damon, and others, and is standardized by NIST in August 2015 as SHA-3. The DAO is a decentralized autonomous organization for the Ethereum blockchain and was launched in 2016. In 2016, the DAO raised $150 million through a token sale, but was hacked and funds were stolen. The result of this was a forking of the blockchain into Ethereum and Ethereum Classic. Non-interactive zero-knowledge proofs, or NIZKP, allow an entity to prove that they have the knowledge of something without actually revealing it. A typical secret is the ownership of a private key. Non-interactive zero-knowledge proofs involve a prover, Peggy, a verifier, Victor, and a witness, Wendy, and were first defined by Manuel Blum, Paul Feldman, and Silvoni Micali in their paper entitled Non-Interactive Zero-Knowledge Proofs and Its Applications. Popular zero-knowledge proof methods include ZK-SNARK, zero-knowledge succinct non-interactive argument of knowledge, and ZK-STARK's zero-knowledge scalable transparent argument of knowledge. Bitcoin and Ethereum are pseudo-anonymized and where the sender and the recipient of the transaction and its value can be traced. Privacy coins enable anonymous transactions. These include Zcash and Monero. In 1992, David Chaum and Torben P. Pettersson published wallet databases with observers in which outlined a method of shielding details of a monetary transaction. In 1992, Audi Shamir, the S in RSA, published a paper on how to share a secret in the communications of the ACM. This supported the splitting of a secret into a number of shares N, and where the threshold value T could be defined for the minimum number of shares that need to be brought back together to reveal the secret. These are known as Shamir secret shares, or SSS. In 1991, Torben P. Pettersson published a paper entitled Non-Interactive and Information Theoretic Secure Verifiable Secret Sharing, and which is now known as the Pettersson Commitment. This is where we produce our commitment and then can show the message that matches with this commitment. Distributed Key Generation, or DKG, the DKG method allows a private key to be shared by a number of trusted nodes. These nodes can then sign for a part of the ECDSA signature without producing, and by producing a partial signature and with the shares of their key. Not all blockchains use ECDSA. The IOTA blockchain uses EDDSA, and which uses Curve 25519 instead of SEP 256K1. This is a more lightweight signature version and has better support for signature aggregation. It uses twisted Edwards curves. The core signing method used in EDDSA is based on the Schnorr signature scheme, and which was created by Klaus Schnorr in 1989. This was a patent known as Method for Identifying subscribers and for generating and verifying electronic signatures in a data exchange system. The patent ran out in 2008. Curve 25519 uses a prime number of 2 to the power of 255 minus 19 and was created by Daniel J. Bernstein. Peter Schnorr defined that elliptic curves could be broken by quantum computers. To overcome the cracking of the ECDSA signature from quantum computers, NIST are now standardizing a number of methods. At present, this focuses on the crystals dilithium method, and which uses lattice-based cryptography. Bulletproofs were created in 2017 by Stanford's Applied Cryptography Group, ACG. They define a zero-knowledge proof as where a value can be checked to see if it lies within a given range. The name of bulletproofs is defined as they are short, like a bullet, and with bullet security assumptions. While Bitcoin can take up to 7 to 10 minutes to mine a new block and create a consensus, newer blockchains such as IOTA can give an almost instantaneous consensus. Banks around the world are investigating CBDC, or central bank digital currency, and which is not a cryptocurrency but a way to quickly define a consensus on a transaction. Homomorphic encryption allows for the processing of encrypted values using arithmetic operations. A public key is used to encrypt the data and which is then processed using an arithmetic circuit on the encrypted data. The owner of the associated private key can then decrypt the result. In some traditional public key methods enable partial homomorphic encryption. RSA and Elgamal allow for multiplication and division, while the Palea method allows for homomorphic addition and subtraction. Full homomorphic encryption, or FHE, supports all of the arithmetic operations and includes the FV and BFV methods for integer operations and HENE, homomorphic encryption for arithmetic of approximate numbers for floating point values. Most of these homomorphic encryption methods use lattice-based cryptography. Some blockchain applications include the BLS curves, and which are pairing friendly. They can be used to implement bilinear groups and which have a triplet of groups G1, G2 and GT. So we can implement a pairing function of E such that E G1 to the power of X, G2 to the power of Y is equal to GT to the power of XY. Pairing-based cryptography is used in zero-knowledge proofs. The main BLS curves are BLS 12, 381, 446, 455, 638, and BLS 24, 477. An accumulator can be used for zero-knowledge proofs, such as using a BLS curve to create the addition and removal of a proof of knowledge. OpenZeppelin is an open-source Solidity library that supports a wide range of functions that integrate into smart contracts in Ethereum. These include AES encryption, base64 integration, and elliptic curve operations. MetaMask is one of the most widely used blockchain wallets and can integrate into many blockchains. Most wallets generate the seed from the activity on the operating system, and where the browser can use the crypto.getRandomValues function, and which is compatible with most browsers. Solidity programs can be compiled with Remix at remix.ethereum.org. The main Ethereum network is Ethereum mainnet. We can test smart contracts on Ethereum test networks. Current networks include Sepolia, Ethernet Scan.io, and Gorelli.net. Ether can be mined for test purposes from a faucet, such as faucet.metamask.io. This normally requires some proof of work to gain the ether in order to protect against the denial of service against the faucet. The private key can be revealed from two ECDSA signatures which use the same random nonce value. Polkadot is a blockchain which allows blockchains to exchange messages and perform transactions. The proof of work method of creating a consensus is now not preferred because of the energy that it typically uses. Many systems now focus on the proof of stake, or POS. A time-locked puzzle / proof of work involves performing a computational task which has a given cost and which cannot be cheated against. This typically involves continual hashing or continual squaring. The Chai blockchain network uses both proof of space, POS, and proof of time, POT. The proof of stake method makes use of underutilized disk space. With a verifiable delay function, VDF, we can prove that a given amount of work has been done by a prover, Peggy. A verifier, Victor, can then send the prover a proof value and compute a result which verifies the work has been done. The verifier does not need to do the work at all, but can still prove that the work has been done. A physically unclonable function, or PUF, is a one-way function which creates a unique signature pattern based on the inherent delays within wires and transistors. This can be used to link a device to an NFT. In blockchain applications, we can use a non-interactive zero-knowledge proof for the equality EQ of discrete logs DL or DLEQ. With this, in discrete logarithms, we have a is equal to g to the power of x and b is equal to h to the power of x, and where x is a secret, and where we can then prove the knowledge of x by showing that the log to the base g of a is equal to log to the base h of b. Thank you.